All right, welcome back, people. So we're going to talk today about topic 3.9, which is material management. Okay, so the purpose of material management is essentially to learn how to cut and shape material, but most importantly, actually preserving as much material as possible and learning about how we can actually preserve as much material using a bunch of different techniques. Okay, and there's going to be a couple of different tips and tricks that we can use to actually reduce the amount of material that we use, but get exactly the same result that we desire. Okay, so here we go. Um, Basically, what material management is, as I said earlier, is conserving as much raw materials that we can while not sacrificing any accuracy, and in some cases maximizing accuracy, or in most cases, while completing the actual job that we have to do. And of course, the main purpose of this is to reduce the environmental impact of actually using the material, and also it helps us reduce the cost because we're actually using less material or using the same material more efficiently, and therefore using less of it. Okay, so there are three ways which we can achieve this. And we're going to start with woods, and we're going to go through this with all three material types. So it's going to be woods, it's going to be polymers, and metals. Okay, so firstly, um, actually cutting the materials efficiently, and in some cases actually not even cutting the materials, but rather buying the materials in the size that we need them. So if you're building something like a frame of some kind, um, and you need, let's say for example, I don't know, a 4 centimeter by 4 centimeter um, sort of strip of wood. So that would be like a square form. Um, you would buy it in 4 by 4 centimeters rather than buying, I don't know, 8 by 4 and then cutting it in half, because then you risk wasting some material, and perhaps you also end up having to process that material yourself, which also you risk making a mistake as well. Okay, so stock forms and stock sizes basically mean um, materials that come pre-processed in an existing size. And this happens in all material types. So this will happen for woods, metals, and plastics. And we'll talk about, or polymers, sorry. We'll talk about all three of them in a moment. But specifically with woods, you might be familiar with the term 2 by 4. That's a really common stock form that's used in the US, but that's in inches. So in our cases, we'll use millimeters, so the measurements themselves will be a little bit different. But most importantly, just actually using stock forms rather than using sort of sheet material or other types of material if the stock form suits our design. And in some cases, you can design around using stock forms to prevent yourself from having to process all this material on your own. And this is very often what people do when they are doing sort of a home workshop situation and they don't have too many tools and they don't have the ability to process things, like we would at a school workshop. They will very often resort to stock forms anyway, because it's a little bit more efficient. Okay. Um, Secondly, marking out the material correctly. Okay, marking it out appropriately, using the right tools, and the purpose of this obviously is to maximize accuracy, but also to minimize wastage by human error. Right? If you just use a pencil and you just draw a straight line or what you think is a straight line, and then you cut down that straight line, you risk making a mistake, in which case you risk wasting that whole piece of material. Right? So there's a couple of steps to that. Most importantly, you want to use a steel ruler, and you want to use a tri-square. A tri-square is simply an L-shaped piece of metal that has a perfect right angle to it, and you can see that in this video here of Mr. Busbridge marking out a lovely piece of stock form there. Um, and using the pencil or marking knife to make sure that you're drawing a really straight line along that straight edge that the tri-square gives you, and of course using a steel rule because it gives you really accurate measurements down to the millimeter, and it actually also starts at 0. If you look at a plastic ruler that you have at home, the start of the ruler won't actually be at 0, it'll be slightly before 0, and then there'll be a dot or a line that indicates where 0 starts. Okay, so that's the first thing. Secondly, if you are marking on a stock form, you need to make sure that one edge of the stock form is actually 90 degrees. Okay, some stock forms have one 90-degree edge that they automatically will plane down as part of the process, but in some cases that's not the case. So it's important that you check that, and the tri-square can help you check that as well, because again, the tri-square has a right angle. And if it's not 90 degrees, you've got to plane it down to 90 degrees using a plane, okay, using a jack plane or an edge plane. Um, this next one's a little bit obvious. Make sure you're using the smallest piece of material that fits your design, right? So if you're cutting, I don't know, a total of 20 by 20 centimeters worth of stuff, there's no need to grab a 40 by 50 centimeter piece of material. There's just no need, right? That's way too much material. You end up probably wasting a lot of it. You end up putting a giant hole in it because you're cutting lots of stuff. Whereas if you can find, I don't know, a 30 by 20 or whatever that fits the actual size that you're using, then it's going to be a little bit better in terms of the actual use of the material because you're making whole use of that single piece of material, right? And then that can go into the recycling afterwards. Okay. Um, and this is another common one that people make mistakes on. If you're cutting something that has a flat edge to it, so if you're cutting a square, for example, there's no need to cut a square out of a piece of sheet material, like out of the middle of it somewhere, even close to the edge. You can have the square bumped up right against the edge because the edge is going to be a 90 degree corner anyway. So if you look at this stock form here in this material, if you needed to cut a square out, you could just cut along the edge and then straight down rather than, trying to cut out a square from the middle of this here and then trying to get a perfect square. Use the edges of the material for straight lines and corners where you can. Okay. This next one is called tessellation. Okay. Now tessellation basically means um, fitting as many designs or as many shapes within the required space as possible. And this might involve rotating and flipping and sometimes mirroring your designs to sort of match them up together to use as much space as possible or as little space as possible, but fit as many designs within that space. Okay, we'll go into that a little bit more later, so don't worry too much. The main thing to be aware of is with this is it's essentially just an efficient use of material space. Okay, and this is mostly going to be in CAD/CAM, but you can also do this when you're marking out things manually. Okay. This last one is an interesting one. It's called datum points. Okay, so datum points basically, a common data point is like an origin point on a graph, right? It's just your sort of zero where you can measure everything from, and you know the data that you're getting, or you know the distance that you're getting from that same point. So similarly in design, we have to have a 0 point. So that might be either the corner of a design or a specific edge or a specific face. And similarly, machines also have datum points or 0 points as well. And so part of our job is to ensure that the machine is zeroed correctly, but also to ensure that um, we've actually set the machine up in a way where it can recognize our design relative to its datum point. Okay. There's a little video on datum points down here, and it's useful to have a watch of that. But we'll go into more detail on data points in a moment. Okay. Right. So we're going to move on here. So we're going to look at how to achieve this with metals now. All right, so with metals, first of all, the thing to be aware of is metals have a lot more stock forms than timbers and also polymers as well. Okay, and this is because in a lot of cases it's a lot harder to trim down metals. It's a lot harder to shape them. You need a lot more tools, a lot more equipment because metals obviously are a lot harder. They're going to be a little bit more difficult to work with, and also they're going to be quite expensive. Okay, so it's better and more efficient for us to sell metals in more stock forms so that everybody can get the sizes that they need without having to trim down so much metal and wasting all that extra metal. Okay, so one of the most efficient ways to cut metal is to not cut it at all and to buy stock forms, right? Now, if you do have to cut it, there's a couple of useful tools. One would be a center lathe, and that's in this video here. And then another one would be a milling machine like a CNC or even a manual milling machine. However, especially with metals, but this is the same with all materials really, any material that you have to trim off or waste does still count towards the cost of the product. Even if you're trimming it down from a stock form, you do have to count the cost of that entire used piece of stock form or material towards the cost of the product. Okay. Now with metals, marking out metals is a little bit different because obviously metals don't take to pen and pencil quite well. So we have to use instead what is called a scribe. And a scribe is basically just a solid metal pen with a very sharp metal tip. There's no ink in it. It's just a really sharp metal tip that you can then essentially scratch marks into the metal with. There's a nice video of a guy using a scribe and an engineer square here for marking out metal. In some cases, the metal doesn't really show the marks that well, or you need to do a lot of marking, in which case you'll use what's called an engineer's blue or layout fluid, which will basically blue the entire surface of the metal, in which you can then scratch in your marks. But then after that, you can then wipe everything down with a piece of alcohol or methanol, and it will clear off all that engineer's blue after you're done doing what you're doing with your marking out. Okay? Right. And then again, we're going to look at datum points with regards to metals. So the metals, the machines that we use for metals are going to be milling machines and center lathes again, but also plasma cutters. These all require datum points, right? With a center lathe, the datum point is obviously going to be the middle of your circle or of your stock form because center lathes specifically are used for round materials and taking pieces of sort of rounded rod material and then trimming them down to different sizes or different thicknesses basically, right? Whereas with milling machines, it might just be the 0 point of the machine, or it might also be a certain point on your product or on your piece of material where the actual cutting head starts from. And then with plasma cutters, a plasma cutter is essentially just a super-powered laser cutter. So very similarly to a laser cutter, you've got your sort of origin point, which in most cases for most laser cutters it'll be the top right of the laser cutter bed, but in some cases it will actually use the top left, and a lot of times as well. The newer laser cutters will actually also measure the thickness of the material and will level the bed as well. So making sure that the bed is leveled with a laser cutter and with a plasma cutter is also a really important way to ensure that your datum points are correct. Okay, right. So let's move on to polymers. Okay, so with polymers, of course you will know this, polymers are very often laser cut. Acrylic is a great example, but there's loads of different polymers that get laser cut, high impact polystyrene and stuff like that. And a great way to save material with that is actually tessellation again. So first and foremost with laser cutting, of course you don't need to use a gigantic piece of material if you're cutting out a small item. Try to find the size of material that suits the size of your actual piece of work so that you don't end up with a giant piece of material with a small piece of work cut out. Otherwise, that giant piece ends up going to waste for someone who could have maybe used that whole piece of material in one go. So this is a very uh, sort of human-centric way of doing it. So, it involves us actually actively doing it. But another thing that we can do that's more of just a sort of positive practice is something called tessellation. Okay, and again, we talked about this before. This is a great example of tessellation here. So this image on the left shows very poor tessellation. You've got these huge gaps in between each shape, both vertically and horizontally. They're very, very spaced out. Whereas if you look over here, they're lined up to one another. And in fact, if you look closely, they've actually made the lines overlap just such that it's a single cut can do one cut for two pieces of material. Because if you see here, if you imagine the laser beam following that red line, it's going to go all the way around here, then it's going to go down to the next one, and then it's going to do that same thing. Whereas for this one on the right here, it'll go all the way around, but when it does this line, that line is also the top part of the bottom shape here. So you're actually reducing the amount of cutting by a lot. In some cases, it's by double, right? Because it's got to do double the amount of lines here, and so you actually save 50% of your cutting time as well as your material. And in a lot of cases, time is money. If you were to go to a laser cutting studio and you would request to use a laser cutter, they would charge you by time. They would charge you by the hour. So the more efficient you are with your time, the more money you end up saving, the more cutting you're able to do within that same set of time. Okay. Now with polymers, if you're marking on a raw piece of polymer, you would use what's called a China graph pencil and an engineer square and a steel rule, obviously. However, some polymers are protected with protective sheets of paper or thin plastic film that's on the surface, in which case you can just use a permanent marker or a permanent pen, and that will take quite well on that piece of polymer there. Okay. Um, and finally, with polymers, most of the time you're using laser cutters. It might vary a little bit here or there. In some cases, you might CNC a thick piece of nylon, or you might put a piece of nylon into the center lathe. But most of the time, you're going to be doing laser cutting, and again, making sure that the machine is appropriately zeroed, the thicknesses have been measured, and the datum points are all correct. Will minimize the chance of human error and therefore wastage, right? So that's a really, really big one. A couple videos here for you to just sort of visually demonstrate what I'm talking about there. Okay. Now, finally, just going to go over the key factors of this section here, the key points. So first of all, of course, stock forms. Once again, metals do have a lot more stock forms than woods and polymers. Not to say that woods and polymers have none. They actually also have quite a lot. It's just that with metals, we really do try, in an industrial sense, to save as much material as possible, and therefore more stock forms are available. But that isn't to say that we don't have any with woods and polymers, right? There's actually a lot. Even when you're buying acrylic tube, you can buy solid acrylic tube, you can buy acrylic rod, you can buy hollow acrylic tube, or you can buy solid acrylic rod. And then within that, you've got loads of different thicknesses. You've got really, really thick pipe, and then you've got sort of very, very, very thin pieces of acrylic tube, almost like straw thickness for smaller, more intricate pieces of work. Okay. Um, Again, using the smallest piece of material that you can to fit all the parts of your cutting job. Now, if you're cutting, 500 very, very small items and you need an entire big sheet of material, then obviously you will go ahead and do that. But you have to make sure then, if that's the case, that you've tessellated everything so that everything fits into that page as best as possible. There's a really good example in the textbook as well. I'll see if I can drag that over here. Down here, you'll see a really good example of a nicely tessellated piece of work here. And this is, you can see there's a lot of material being saved on these edges here as well. Okay. Sometimes tessellation is also called nesting, but most of the time it will be called tessellating. So I recommend you just learning that term. It's a bit tricky to spell sometimes. Double S, double L. That's usually how I remember it. Um, Finally, waste material needs to be considered as part of the cost of the final item. So whatever you end up using as part of your manufacturing process, even if some of it gets trimmed down or wasted down, that still is considered part of the cost of the final item. And therefore, we actually do try, of course, because of that, to minimize as much trimming as possible. We try to get everything in stock form as best as we can. Okay, and then ensuring finally that your design has a datum point in which accurate measurements can be taken from that datum point to any point on your design. And then of course, if you're using CNC machines, meaning computer controlled machines, that the machines have actually been zeroed and the datum point is very clear to you, so that you know that the machine is doing exactly what you expect it to. To reduce any chance for human error or any chance for mistakes to occur. Okay, right. That's it. It's a pretty short unit. Um, have a go at this Quizlet to test your knowledge, and then there's also some exam questions here with the mark schemes to get an idea of the way these questions are asked of you in the exam. Okay, thanks for watching, guys. Good luck.